Okay, so Math 10s today is a really, really important part of this unit. I gave you a lot of practice questions to go through, but the first part of the unit was solving graphically, then solving through elimination and substitution algebraically, and then this is like the fourth part of the unit. And it's all about application questions, and that's super, super important for this unit. So don't kind of move on and be like, whatever, Mrs. Reed won't do an application question on the quiz coming up this Friday, but I will. Application questions are really, really important in this unit, especially because last unit, I really didn't do any application questions. So I really want to see your skills here. So a few really important things to remember with application questions, and maybe you can, I'll write these things down at the top here. Application questions when you're working on these ones for systems of equations. So this is not talking about application questions in every question that you would work on. It's only in these types of questions. So especially when it says create a linear system, that's what I want you to do with these steps. So one of the really important things is you need to create two equations. And within those two equations, you have to have two variables, and those two variables need to be the same in both equations. So I'm just going to write the same. Hopefully that makes sense. Same in both equations. Maybe I'll write that. Same in both equations. Okay. I always like to use X and Y for all of these questions. The textbook really likes to use like L and R and C and B and whatever makes sense for the question. You can totally do that. You can use any variables you want. I find it just simplest to use X and Y for everyone, but it's up to you. So once you have the two equations with the two variables, the same variables in both equations, then all you have to do is solve. And hopefully Math 10s, you remember how to solve. You can solve using elimination or substitution. So your choice. Okay, so that's really nice. So once you get the two equations, you just solve it. Yeah, and I think that's all. In every question, I'll start with the top ones a little bit slower, and the ones later on, I'll go a little bit faster, but it is so important to establish clarity right at the beginning of the question. If you're confused, I'm going to be confused marking your test. So try to make it really, really simple for yourself. And the more questions you do, the easier this will be. So really, really important in this first one is to establish your variables. So I'm going to label X and Y. Okay, so there's always going to be like two things that are being compared. So one of them is going to be X, one of them is going to be Y. Okay, so let's read this. 1, create a linear system. Remember, a linear system is two equations that work together with the same variables. So that's exactly what we're doing here. To model this situation. So the perimeter of a Canadian flag, they've given you a little picture there, is 16 feet. So the perimeter is 16 feet. Its length is 2 feet longer than its width. Okay, so it's really good if they don't give you something, draw it for yourself. If it's a question about perimeter or area or anything like that, draw it for yourself. It's probably not going to be area because that would involve squared, an exponent, and we don't do exponents with these ones. Pardon me. Okay. Perimeter of a Canadian flag is 16 feet. So I'm going to write that down. Really important. You're documenting all this important information. So P equals 16 feet. So the perimeter equals 16 feet. Now, what do we know about the perimeter? Well, the perimeter also means P equals 2 times the length plus 2 times the width, right? That's also what we know. Okay. But I told you I don't want to use L and W, I want to use X and Y. So I'm just going to really simply replace that 2X plus 2Y. Okay, so all I've done, you guys, is I haven't even really thought about what a linear system is. I've just gone, okay, so the perimeter is 16 feet. So we know that that's like, a really important part of this question. So then the other thing is we can't have a p in our linear equation, right? Obviously we can only have x and y. So then again, I'm going to do one more arrow here. 16 is the p, equals 2x plus 2y. Okay, I'm going to give that a little circle because that's one of my equations. Okay, using everything from the question to describe part of the linear system. Okay, now the other part of the question is its length is 2 feet longer than its width. So if I look over here, I'm going to make this the length and this the width. Again, you guys, it doesn't matter what I do here for labeling x and y. Okay, so there's no fancy like everything, x is always this variable, and that doesn't happen. So label it anything you want. So I'm going to do this the width, which is x, this the length. So what it's saying is its length is 2 feet longer than its width, which means to describe that, I'm going to show that right here. That means its y, its length, equals its width, x, plus 2 feet, right? Its length is equal to its width, that's what it's saying here, but its width is 2 feet longer. Just longer, not 2 times as long. Then I would multiply. But this is just saying this side is 2 feet longer than this side. Okay? So there's my second equation. Okay. So that's all I had to do in that first question, is I just had to find the linear system. Okay, part B. Anna has determined that the Canadian flag is 5 feet long and 3 feet wide. Use the linear system from part A to verify that Anna is correct. So all you guys have to do here is we just have to sub in to verify to see if Anna's correct. So let's do that. So these are our two variables they've given us. So they've said it's 5 feet long, which we said was length, and our x we labeled as our width, which is 3. So we're going to substitute those into our linear equation. So let's do one at a time. So I'm going to go y equals x plus 2, sub in my y, which is 5, my x, which is 3, and then 5 equals 5. Did we verify? Yep. And then my other one, 16 equals 2 times 3 plus 2 times 5, 16 equals 6 plus 10, 16 equals 16. Check. Okay, and if that whole question was a little bit overwhelming, that's okay. It's all good. I'm going to go through more today, more questions, and there's some really helpful things in the textbook as well. Okay, the more application questions you guys do, the easier they will be, I promise. Okay. Question 2, create a linear system to model this situation. So here I helped you out with giving you a graph. Now, a lot of students like using a graph. I don't particularly like using a graph because I find it like you don't always know if you're using the column or the row or what you're supposed to use, but this can be really helpful if you find this helpful in this question. So create a linear system to model this situation. So ABJ raised $195 by collecting 3,000 items for recycling. The school received 5 cents for each pop can and 20 cents for each plastic bottle. So we're just going to put everything in here that they've told us. So the refund per item for a can, so in dollars, so in cents, for a pop can is 5 cents. And I like to underline everything as I use it. So 0.05. So you can't put 5 cents, you guys. You can't just go like 5 cents in your calculator, right? You have to actually put it as a decimal, 0.05. And then the refund per item for a bottle is 0.20 for each plastic bottle. It's not overly important to know this right here, that this is going to be 25 cents. So you could put that in. But that's not really important to the question. So I'm just going to put a little slash through there. What is important is this other part here, raised $195 by collecting 3,000 bottles for recycling. So number of items. So again, there's always two things that are working together, and we have to label one an X, one a Y. What are those two different things in this question? It's not money and bottles. The two different things in this question are pop can, plastic bottle. Just like up here, it was length and width, okay? So let's label our pop can X and our bottle Y, which means we don't know how many pop cans they did. So we're just gonna put an X here, and we don't know the number of items of bottles that they did, but we know that it totals 3,000, okay? So that right there is gonna be one of your equations. X plus Y equals 3,000, okay? And then the money raised, let's do that at the bottom. 0.05 X, right? 0.05, so 5 cents multiplied by your number of pop cans will give you the dollar amount, right? When you go to the bottle depot, that's what they do, right? You have 50 pop cans, you're gonna multiply your 50 pop cans by 5 cents, okay? And then your bottle here is 0.20Y, right? 20 cents per bottle. And then all of that equals how much? $195. So that right there is your second equation. 0.05x plus 0.20y equals 195. Now, some students really struggle with application questions, and some students, they come really easy to them. So if for you, this question with this graph does not help you, this chart, you're like, that's so annoying, don't use it. Just do this question on your own. But for a lot of students that struggle with application questions, this is really, really helpful. Now, I want to explain what I said here. So I said this total wasn't important here. It's because there's no X and Y value. So I wouldn't circle this as one of my equations because it doesn't have an X and a Y. Remember at the top, both equations have to have an X and a Y. So that's really nice. And if you look at these two equations, they make sense. Number of pop cans plus number of bottle cans will equal 3,000 bottles and cans. And then 0.05, so 5 cents times the cans, and 20 cents times the bottles will equal $195. So everything from the question is in those two equations, okay? So then B, the school collected 2,700 pop cans and 300 plastic bottles. Use the linear system to verify. So sub in to verify. Hopefully you guys are getting really good at this. So X plus Y, so our X, they said, well, up here we put our X as our pop cans, which here they got 2,700. And then their plastic bottles, we said was Y, right? Plastic bottles, Y, so 300. So then X plus Y equals 3,000. That's our initial equation. We're gonna sub in 2,700 plus 300 equals 3,000. 3,000 equals 3,000, right? Check mark. Let's do the other one. A little bit more work in this one. May involve a calculator as well. Oh gosh, running out of room. 0.05 times 2,700 plus 0.2. Oh, I can't do this all at the same time because it's bed math, so sorry. 0.05 plus multiplied, times 2,700 is that 135. So I'm just going to chuck that in. And 0.2, holy, this morning, times 300 is 60. 195. And then 135 plus 60, 195. Check mark. Fabulous. Okay, this last question I'm going to do in the next video.